Hi guys, this is the 1.3 day 2 video. We're going to be talking about the angle addition postulate, and this is actually super similar to the segment addition postulate, which we've already learned. So feel free to pause the video and get the vocab down. I'm going to talk through a couple of them really quick, and then we're going to do the examples together. Okay, so an angle measure. So you guys are familiar with what angles are. In our last video, we talked about acute, obtuse, and right angles. I just randomly put a 30-degree angle here. Remember, we name an angle with 3 letters. The angle at the point where the point at the vertex is that place where the rays meet and form the angle. So measure means they want to know the degrees. Okay? So this little m stands for measure. So this says the measure of angle SRT equals 30 degrees. So it is the measurement in degrees. Okay, interior of an angle means it's somewhere in between those two rays. If it's the exterior of an angle, it's outside those two rays. Angle bisector. So remember, bisect means to cut in half. So instead of cutting a segment in half, we're cutting an angle in half. So these markings right here, you can have, I'm going to show you, oh yeah, I guess we got 2 different ones. So it doesn't have to have the tick marks on it. It can. Another way it could look, draw a mini one, is it could just do that. And if it's the same number of arcs, that also means congruent. So I might do like 2 arcs and 2 arcs. That means they're congruent as well. As long as it's the same marking on each angle, that's how we know they are congruent. Okay, so an angle bisector cuts an angle exactly in half. So if AB, so this is the ray AB, if it's bisecting angle DAC, that means that angle DAB, that top part of the angle, and angle BAC are congruent. We automatically know that if it's cutting something in half, those 2 halves are congruent. And just to remind you what congruent means that they have the same measurement. So again, here's a picture. They have the same marking. Angle D is congruent to angle A. I could also use 3 letters there. I could use 1 because there's really no confusion. Angle D is just talking about that angle. So this says if the measure of angle D is equal to the measure of angle A, then angle D is congruent to angle A. So it's basically saying if their measurements are equal, then they're congruent. The opposite is true as well. If they're congruent, then their measurements are equal. So notice this one uses an equal sign and the little m's. This one without the m's uses a congruent symbol. It's a small difference, but it is important. Okay, lastly, angle addition postulate. Okay, so here I have 2 angles. Notice the markings are not the same, so they're not congruent. And I have this angle. So here's the postulate, what it says, the definition says, if S, so S is a point, is in the interior, so somewhere in between this angle, RQP, so S is inside angle RQP, then the measure of RQS, so the whole angle, or excuse me, this top part of the angle, RQS, plus PQS is equal to the whole thing. So it's the same as the segment addition postulate. Add the 2 parts of the angle to equal the whole angle. Okay, we're going to do a couple examples with those, you guys. All right, so it says for all examples, draw a picture and justify the first step. Remember, justify means give the definition, theorem, or postulate that supports what we're doing. Okay, so I'm going to draw this picture. L is in the interior of angle JKM. So I'm going to draw angle JKM. So JK has to be the vertex because it's the middle letter. And then L is somewhere in between. I like to not put it right in the middle just so I don't make myself think that those 2 angles are congruent. So I'm just going to put it kind of closer to one of the rays of the angle. And I'm going to put L. I know it just says point L. I like to draw the ray through it so that I can easily see there's 2 smaller angles there that add up to the whole angle. Okay, so they're telling me the measure of angle JKL, so the smaller one, is 56.4 degrees. And the measure of JKM, so the whole thing, this whole thing, is 82.5. Okay, so, and maybe actually my picture isn't to scale, but that's okay. So they want me to find LKM. So they want me to find the smaller piece here. So we know that the two smaller angles have to add up to be the whole thing. So one of the smaller angles is 56.4 degrees. The other smaller angle is LKM. We don't know that one. So because I'm in an equation, I'm talking about the measurement of angle LKM. So I do want the M in there. And the whole angle together is 82.5 degrees. So so basically the setup of this is saying add the two small angles to equal the whole angle. That is our angle addition postulate. I'm going to abbreviate a little bit here. Okay, and then they want me to find LKM. So I don't have to justify the rest of the steps. I'm just going to get LKM by itself. So I'm going to subtract that 56.4 from both sides. And when I do that, I get the measure of LKM to equal 26.1 degrees. All right. Okay, next one. Ray BD bisects angle ABC. Okay, so we are going to draw angle ABC. So I've got A, B has to be the vertex. C, this is bisecting, so I do want to draw it right down the middle. And there's Ray BD. So because it's bisecting, I know that this angle and this angle have to be the same, right? It's going right down the middle, so the two halves are congruent. Okay, so they're telling me the measure of ABD is 5y minus 3 degrees, and DBC is 3y plus 15. Okay, so I already stated I know those are equal. They want me to find the measure of ABC, but first I have to know what y is. So I'm going to set up an equation to find y. So I know this angle is equal to this angle, so I'm going to set that up as an equation. And the reason I know those are equal is because of that word bisect. So I'm going to say definition. You could just say definition of bisect. I'm going to be a little more specific. I know it's bisecting an angle, so I'm going to say definition of angle bisector. Okay, so let's go ahead and finish the problem. So I'm going to solve this equation. Rewrite it here for a second. Okay, so I'm going to subtract 3y to get all my y's on one side together. So I've got 2y minus 3 equals 15. Okay, now to get y by itself, I'm going to add 3 to both sides. So I've got 2y equals 18. And then lastly, to get y by itself, we're going to divide both sides by 2. So I now found y. They want me to find ABC. So there's a couple ways I can do this. I'm going to plug y back in. I could plug it into both and add them together. Or I could just plug it into one of them and multiply by 2. Because remember, these are the same. So I'm going to just plug it into that first one. So I've got 5y, but we now know y is 9. So this is the measure of angle ABD. Okay. 5 times 9 is 45, minus 3 is 42 degrees. So that's the measure of angle ABD. D. If we multiply that by 2, that would give us the whole angle, which is ABC. 2 times 42 is 84 degrees, and that's what we get for angle ABC. All right, last example here. Okay, this one we're doing a full proof. They want the reasons and justifications the whole way down. Okay, so we have A is in the interior of CBD. Okay, so I don't know that it's in the middle. I just know it's in between, kind of like our very first example. Oh, but they do tell me CBA and ABD are congruent angles. Measure of ABD is this. Okay, so we are going to say, I'm going to draw a picture maybe down here, you guys, and then I got room for my statements and reasons. Okay, so I have angle CBD, and we have A is in the interior, but they did tell me that CBA and ABD were congruent, so I am going to put it in the middle. All right, because they told me CBA and ABD are congruent. Okay. Let's see, they're telling me ABD is 6x plus 3. and DBC, the whole thing is 8x plus 27. Prove ABD is 34 degrees. Okay, so again, we gotta find x. Okay, so we are given some important pieces of information here, specifically about angle CBA and ABD being congruent. Okay, so we know because of that, then their measurements are equal, right? The measure of angle CBA is equal to the measure of angle ABD. How did we know that their measurements are equal? Because of that, because they're congruent. So this is the definition of congruent angles. And I'm using symbols here. You are welcome to do the same thing. Okay, so then I was given ABD is 6x plus 3. That means CBA also is 6x plus 3 because we just said their measurements are equal. So the measure of angle CBA equals 6x plus 3. So what I did here is I took out ABD and I put in 6x plus 3. Anytime we're replacing something with an equivalent expression, that's our substitution property. Okay, so now we know, back to my picture here, this is also then 6x plus 3. That's what we've stated so far. So now I have two small parts and the whole angle. So we know that two small pieces have to add up to be the whole thing. So I'm going to set that up as an equation. 6x plus 3 plus another 6x plus 3 equals the whole thing, which was given to us as 8x plus 27. Whenever we add the two small parts to equal the whole, that is an addition postulate. For us, we're adding angles, so it is the angle addition postulate. And now we're just going to solve. We're going to use our properties of equality to solve for x. I'm going to combine some like terms, so I've got 12x plus 6 equals 8x plus 27. You can call that simplify or combine like terms. I'm going to abbreviate combine like terms. Okay. I'm going to get my x's together, so I'm going to subtract 8x from both sides. I'm going to do this in one step, you guys. You could do this in two. I'm also going to move my 6 to the other side. So I'm using the subtraction property of equality twice there. So I'm subtraction, POE. I'm left with 4x. My 6 is gone. My x over here is gone. 27 minus 6 is 21. And remember, after we use a property of equality, we're just doing the math. That's just simplify. Now to get x by itself, we're going to divide both sides by 4 using our division. Oh, not division property of equality. 21 divided by 4 is 5.25 when I simplify. Okay, so look at what we were trying to prove. We were trying to prove what ABD equals. So ABD was 6x plus 3. So now we can plug in what we got for x. So the measure of angle ABD is 6x plus 3, but instead of x, we're going to substitute what we got for x, 5.25. So that is, again, substitution when we're replacing with an equivalent piece. Okay, when I simplify here, I multiply 6 by 5.25 and I add 3, I do get 34.5 degrees when we simplify. I ended with what I was trying to prove, so we are done. Okay, that is it for this video, guys. Thanks for watching.